Okay, this video has to do with double angle identities, and you can see I have all the double angle identities listed here for you. These are all going to be on the trig identities sheet that I give you that references all the different formulas and things that we've talked about so far. So please make sure you have that handy when you're doing these problems. You can use everything right off of the reference sheet. You do not need to memorize these. So you'll see that for the sine of a double angle, there's only one formula for that. It's just 2 sine theta cosine theta. You'll see, however, that there are 3 different formulas for the cosine of a double angle. And we're not going to go through the derivations of them. Just understand that depending on the situation you have is going to determine which of those 3 particular identities you're going to use. And then you'll see on the bottom there's only one option for a tangent of a double angle. Again, you don't need to memorize these, but just recognize that they are on that sheet for you to reference. So how do we use these? Well, let's start out with an example problem. This first one says if the sine of theta is 4/5 and theta is between pi over 2 and pi. They're saying find the sine of 2 theta and cosine 2 theta. Okay, so I know that it is in the second quadrant because it's between pi over 2 and pi. So I'm going to go ahead and draw that out first. Very similar to some of the problems we did before as far as drawing ourselves a picture to start. Okay, so just a rough sketch. Here's my theta. Sine is opposite over hypotenuse. And if you recognize this is a 3, 4, 5 right triangle, you can just go ahead and put that in. If not, you could always do Pythagorean theorem to find that missing side. Remember, because I'm on the negative side of the x-axis, the net value has to be -3. So now I'm just going to go ahead and plug into my formula using the values I need right from my picture. So I have sine of 2 theta. And the formula for that is 2 sine theta cosine theta. So I've got 2 times the sine of theta. Sine of theta that was given to me, that's 4/5. And cosine of theta, I'm going to get off of my picture, that's going to be -3/5, which makes sense because I'm in the second quadrant and cosine is negative in the second quadrant. And then I'm just going to go ahead and multiply those together. So I have 2 times 4 times -3, so it's going to be -24 over 25. And that's my answer. Very straightforward. Just figure out which formula you want to use. Actually, for sine, there's only one formula to use for sine of the double angle. But just find the formula that you want to use and plug in the missing values. For the cosine of 2 theta, because we know the sine and the cosine in our picture, it doesn't matter which formula we use. We really can use any one that we want. So I'm just going to choose the first one. I'm going to do cosine squared theta minus sine squared theta. And cosine of theta is -3/5. I'm going to square that minus the sine of theta, which is 4/5, and I'm going to square that. So -3/5 squared is going to be 9/25, minus 4/5 squared is going to be 16/25. So 9/25 minus 16/25 is going to be -7/25. And that's your answer for those. Again, draw yourself the picture and then just use the formulas and the picture to do the computation. Okay, in example number 2, we're going to verify the identity. Remember, when we're verifying, we're doing everything only on one side of the equal sign, right? We're not going to do anything across the equal sign. So what we want to do is we want to simplify things down into something that's more reasonable to work with. Tangent, I know I can simplify into sine over cosine, so I'm going to do that on the left. And then on the right, I know I only have one formula for sine of 2 theta, so I'm going to go ahead and fill that in. 2 sine theta cosine theta. And now I have 3 choices of formulas I want to use for cosine of 2 theta. So I've got that one here, and then I've got minus cosine of 2 theta. Remember, I have 3 formulas that I can choose from. Well, I'm probably going to use one that makes a little bit of sense. So for example, if I use this third one, maybe that's going to be easier to get rid of something in my problem. Maybe not. Let's go ahead and have a look. So I've got 1 minus something over 2 sine theta cosine theta. Okay, so if I use that one, if I use this third one, 1 minus 2 sine squared. So I've got 1 minus 2 sine squared theta. Well, let's see if that gets us anything. So if I distribute that negative, I have 1 minus 1 plus 2 sine squared theta over 2 sine theta cosine theta. 1 minus 1 is 0, so that just gives me 2 sine squared theta over 2 sine theta cosine theta. And now you'll see that my 2's cancel and one of my sines cancel. So I'm left with sine theta over cosine theta, which is what I had on the left. And there is my verification. Now you might be saying, well, how do I know that that's the one I should have used? Well, you could have tried either one of the other 2, and you wouldn't have gotten very far. You would have maybe put it in and then not been able to do anything with it. And if that's the case, then you know, well, hey, maybe I need to move on to one of the other formulas for cosine 2 theta. Okay, I just went with this one because I knew it was going to work out, just to show you how to walk through that. Okay, and then the last problem on there is this one. We've got secant of theta is a negative 4/3, and theta is between pi and 3 pi over 2. Okay, so from this information here, I know that I'm going to be in the 3rd quadrant. So I'm going to go ahead and draw that in the 3rd quadrant. So here's my angle in the 3rd quadrant. Secant flips cosine. So secant is going to be hypotenuse over adjacent, and that's going to be negative because I'm on the negative side of the x-axis. And now some people, they see 3 and 4 and they think, oh, 3, 4, 5. But remember, 5 would have to be the hypotenuse, which it's not in this case. So we're going to go ahead and do that Pythagorean theorem to just find that missing side. So I've got a squared plus b squared is c squared. A squared plus negative 3 squared is 4 squared. I have a squared plus 9 is 16. A squared is 7, and so a then is square root 7. Now again, because I'm on the negative side of the y-axis, I want to make that negative. That way I take care of all the negatives where I need them, so I don't have to worry about them as I'm going through the problem. Okay, so we're doing the tangent of 2 theta. And the formula for tangent of 2 theta is 2 tan theta over 1 minus tan squared. So tangent, we've got 2 tan theta over 1 minus tan squared theta. Okay, so we can go ahead and just plug those values in. So we've got 2, and then the tangent of theta. Tangent is opposite over adjacent. So negative root 7 over negative 3. So that's going to be root 7 over 3 over 1 minus root 7 over 3 squared. From here on in, then, it's just algebra. That would be 2 root 7 over 3 over 1 minus 7/9 if I square root 7 over 3. 1 minus 7/9 would just be 2/9. So I have 2 root 7 over 3 divided by 2/9, which is the same as 2 root 7 over 3 times the reciprocal. My 2's cancel. 3 goes into 9 3 times, and I'm left with 3 root 7 as my answer. So these formulas are very easy and very straightforward to work with. Again, you do not need to memorize them. They're on the reference sheet that I'm giving you. Just understand you want to draw yourself a picture first, and that will help you when you're solving these problems. All right, till next time, thank you.